Hello, everyone, and welcome to the next edition of Slaves to the Algo. I'm Suresh Shankar, founder and CEO of Crayon Data. And today I'm really pleased to have with me a true visionary in the age of algorithms. He was in the age of algorithms before we started talking about the age of algorithms. I'd like to welcome Jeff Jonas, founder and CEO of Senzing, but also a visionary and a person who literally has been involved in the idea of entity resolution for decades. Welcome to the show, Jeff.
Thanks. As if anybody's heard of entity resolution.
No, but you've been talking about entity resolution for literally decades, and you've been doing this, and you've been doing this whole thing of how do I actually use data in many ways. You've been a pioneer in this stuff, right? So perhaps I should, Jeff, I think you're a person that's much more than that. So I should let you introduce yourself before we get straight into the details.
Okay, so you want a quick intro? I've spent most of my life building custom software. I've probably designed and built and deployed about 100 different systems over a wide range of kinds of fields. But over that course of time, I discovered that more and more, one of the biggest problems organizations have with data is the inability to connect it. Duplicates in data, duplicates across systems. And if you can't figure out what data is related to what data, you can't make very good decisions. So over the course of my life, I've become more and more focused around this one little problem, which it goes by a lot of different names, but like in healthcare, it's patient record matching. In marketing, it's marketing list dedupe. If you're a bank, it's like sanction screening, record matching, or fuzzy matching. But man, it's all entity resolution. It's everywhere. So anyway, I've become obsessed with that. I sold my last entity resolution company to IBM in 2005. And then while at IBM, I started working on the next generation version that's way more advanced. Probably spent $50 million building it and spun Senzing out. So Senzing's not a startup. You probably haven't heard of the name, but we're a reincarnation. It's a proven team, proven tech. We just have a new birthday and a new name.
And I met you at IBM, and it's very interesting because you actually bought back what you were doing at IBM because you wanted to reincarnate it, as you just said, right? And what made you do something like that? I mean, most people are happy with the exit. You actually unexited back to yourself.
IBM didn't even think I was going to stay at IBM. I stayed 11 years. No founder CEOs even stayed that long. But I'm obsessed with my work. And entity resolution is just so pivotal. But anyway, while at IBM, I'd invented this new breed of thing. And then I decided I want to get back to my entrepreneurial roots. And IBM gave me a really unique, one-of-a-kind spin-out.
And that's really nice to know. And I think for my audience may not know this, but Jeff was a distinguished scientist and a fellow at IBM as well. So highly credentialed in an academic and in an entrepreneurial sense.
Academic is an overstretch. It's an overstep because I didn't finish high school.
No, I didn't mean it. I don't mean academic in a titular sense. I mean academic in a really deep understanding of a subject. And I'm actually going to segue from something that you just said, right? You were doing a lot of things, and then you kind of come narrower and narrower and narrower and narrower, and you do this one thing. But that one thing for you is the root of everything, right? In a way, I mean, if I were to describe it. So that's a fascinating journey. So tell us how you kind of came down into this one little thing that is at the core of everything that we do in data.
The very first system that I built that was matching identities, and it took years before I realized it was a trend, and it was something inside of everything, almost everything. But it was work for a collection agency that goes and collects bad debt, and they would send 5 notices to the same person. One was 5 different debts, or call them 5 times. But you really want to just call them once and go, hey, you have 5 bills. And, I built that in the 80s and didn't think anything of it. And then in the early 90s, the casinos wanted to combine data, their guests, their loyalty club, and then they wanted to see how that related to like people that they shouldn't let into the casino. And that's a matching problem. That's an interesting matching problem because people that are clever, like kind of evil, clever bastards, so to speak, are they don't use the same name and address on every record. Like they're always just one person had 32 different names and 5 different dates of birth. So how do you do that? So we solved that in the 90s. And then I built another one and another one. I built 5, my team and I built 5 of these engines before we realized we were building the same engine over and over for different purposes. And then we started to generalize it. And then over time, you just realize it's at the center of healthcare. It's at the center of banking, KYC, and AML. It's at the center of marketing. I mean, if you can't combine data, you can't make high quality decisions with the algos.
And, Jeff, this is a fascinating thing of how algos have gone from literally human beings looking at something to you automate one or two steps, and then you say this is the, ultimately over a series of steps, you come to an algo that is literally at the core of all kinds of decisions that you need to make, right? And you spent about 3 decades in this. If I were to ask you, not just an...
Can you get out of here?
I'm trying to make you young now.
Okay, go.
Okay. But the question I have for you is this, right? I mean, in all these decades, it's not just entity resolution. You've been exposed to a wide variety of what we know. Everybody talks about algorithms and AI. What do you think are some cool examples of things that you've seen, either as a consumer in your business life, not necessarily only in entity resolution, something to say, hey, wow, that is really cool. How did they actually create that stuff?
Are you asking me which algos I find the most fascinating?
Yes.
Well, I'll tell you the algos that probably are the most impactful are the ones that are gamifying our experiences and keep pulling us in to check LinkedIn over and over, or check Facebook over and over. Those algorithms that are so tailored to you and your data to figure out what to present to you next, to bring your eyeballs back. I think that's very interesting set of algos. I also think that when we use search engines, which have really changed the whole world, what you see is more and more being tailored to you. It's not actually what's on the internet. You're looking through a lens, and I think people forget that we're looking through a lens. If you search for a certain topic in the Middle East, you get a different kind of set of things than if you search, in the U.S. or in the South, or it's me versus somebody else. And that, I think, is really interesting.
And it kind of really talks to the idea of being a slave to the algo. I mean, you talked about the LinkedIn and the Facebook feeds and all that. In a sense, we're being, quote unquote, the algo is manipulating what it shows you, right? But the algo itself doesn't have any kind of intent apart from making you come back for more.
Right. But then, we're I don't know, have you heard, I haven't read much on it, but the biome in your stomach has a lot more to do with your what you wanted, how you behave than you think. And I think algos are shaping how we interact with the world in ways that people aren't being cognizant of. Like what you
Absolutely.
see, really a machine has picked a lens for how you are going to see the world. You search for 9/11 conspiracy in some parts of the world, and it's all you read about. And you search in other parts of the world, and you read about something different. And it also builds bias, which I think is a big developing problem in the world. Is different points of views that are very even aggressive towards each other.
And that is so true, because what you're saying is the algo may not start with bias, but as it shows you the thing, and then it kind of starts to learn and do more and more things around you, it is entrenching some biases. But there are also good things that algos have done, right? I mean, recently, I'm sure you read about the DeepMind, the protein folding thing that they've went out and did out there. So anything that you've seen that, says, wow, that is really cool and good for stuff.
Oh, the happy side of algos.
Yes, the happy one, not just the dark side.
Yeah, I do a lot of work in privacy, so I'm often thinking about ways to make algorithms more fair. So that's why I went there first. But just as much as LinkedIn is a great example of something that my revisit rate is quite high. The people that it brings forward and says, here's their birthdays or anniversaries or job changes. It's not all 8,000 of my people every day. I'd never be able to respond to them all. But it's certain people, and it's great. And it really improves my journey and builds deeper connections, because I actually go and respond to those people. Every single day, if somebody has a birthday or a job change, I send them a personal note. And so that's enhancing my relationships and connectedness with people.
I'm going to wait for that birthday wish next year, Jeff. See whether I'm on that list of people who shows up on your feed.
Yeah, but if LinkedIn doesn't put you on there, then the question is, who am I missing? I think it's doing a pretty good job, but it's a lens.
But you talked about privacy just now, Jeff, and I know you've been a big fan of this. And the two worlds that you live in, the ability to actually resolve identity or an entity, is also kind of very deeply linked with privacy. So let's just take a step maybe a little bit deeper into this whole idea of entity resolution, right? And we briefly touched upon the fact that it's the core of everything that you do. And you have many people pretending, you have the fraud obviously, but you also have, but I don't know now, for example, when I go onto a site, whether the review is a real one, whether the person I'm dealing with is a real person or not. How do you actually use, how important is identity resolution? And could you share a few examples of how you're working towards solving, I'm not going to say world peace, but solving some real problems around identity?
When it's a fake person, it's a synthetic identity. And so one way is that you find lies in data. If I were to tell you a lie right now, like if I told you I'm 51, you wouldn't know whether that was maybe true or false unless you had some other data to compare it to. So the way you find lies in data is you take a claim or an observation, and then you find other data to compare it to, and that's how you find disagreement, dissent, and lies. And so that holds true with entity resolution as well. But that's in the case of like a synthetic. One of the projects that's entity resolution heavy is the work our software is doing voter registration in the U.S. The U.S. is a very mobile population. Pre-pandemic, heard of that, changed everything. But people move every 5 years on average, and when people move, they forget to unregister. So they move from Colorado, and then they go to California, and then they register in California, but they forget to unregister in Colorado. You end up with more people on the voting roll than live there. Now, you can still be on the roll if you own property, but you just can't vote in a federal election. And so, but it brings discredit to the election rolls because someone will go look at it, and there's people that don't live in the state. That's just because people forgot. That's an entity resolution problem. And so a nonprofit uses Senzing's entity resolution to take voters and Department of Motor Vehicle data, which just gives you a secondary data point, help match better, across 2/3 of the country is doing this, over 30 states. And what it does, it allows the nonprofit to reach out to Colorado and say, hey, this voter apparently is moved to California. You might want to communicate with them and see if they still want to be registered.
Nice.
Yeah.
And so, that's obviously a big topical issue right now, obviously, given where the US election has been. But here's a case of, I think, where you're trying to use the identity to resolve, in a sense that, for good nonprofit situation. Are there any other such examples where, for example, I know it's very big in security. I know it's very big in KYC, etc. And all of these are now becoming increasingly complex because people are very good at synthetic identities. Am I right?
Did you say people are very good at synthetic identities?
At creating all these kinds of things. And yes, maybe there's a better, how does the algo actually go out? Because no matter what I do, if I create 6 IDs, there is some part of me that's that's going to leave a trace, right? So how do the algo actually work in resolving that all of this is actually one person? That's me.
Yeah. I don't know, how many email addresses do you have that are active?
That are active, probably 4, but I probably have some 9 or 10 which are lying around and never deleted them or don't use or whatever. Yeah.
And, I have 4 too. And it's very common in communications and transactions to use different channels. You use your work credit card to purchase this, personal credit card for that. You'll use your, this email address for these communications and this for that. Then you'll jump over and be talking to somebody on LinkedIn. And So it's a multi-channel system. If something wants to, if you want to understand your communications with even one of your friends, you might actually have to go personally aggregate that and look across these different channels to figure out what you've been talking to them about. I mean, you've been saying this on Signal, this on Facebook, and this is happening to businesses, and the data is scattered. And some people, interestingly, intentionally do channel separation because they're hiding stuff. No one, we had the diesel fuel fertilizer and the truck, right? They made a bomb. Like, I suspect nobody goes and buys a ton of fertilizer, a ton of diesel fuel, and rents a moving truck, on the same day with the same identity. They probably don't do that unless they're idiots. And by the way, you and I do channel separation. If I were to email you an encrypted document and then call you with the password or use a different channel, that's channel separation. And so one of the roles of entity resolution is to do channel consolidation. You have to know, is it 3 different people with 3 transactions or one person with 3, is it 3 people each with 1 transaction or 1 person with 3 transactions? You can't find risk or opportunity and make good assessments if you can't see the difference between that. And the technique that we use, just to fast forward, is called entity-centric learning. What that means is, as record 1 and 2 find each other, because the names are similar and the address is close, so messy, maybe one of the records had an email and the other one had a phone number, and now you've just learned both. So both records kind of have learned off of each other. And now with that richer view, you can find yet another record, and now you've learned their middle name. Then you learn a nickname, then you learn an AKA. So you're assembling over time, like in a resume, the different attributes. And you're using that union of that view to find more records that are the same, as well as help you realize when it's not the same. False positives can be pretty destructive. You're tapping on the wrong person.
I just want to go a little deeper into that, right? I mean, none of this stuff is static. I mean, I do one thing and I'm on one channel, I do something else, another channel, I use different types of identity. We have bots that are creating all of these things now and going out and doing, you go and look at some of the Facebook pages. Now I've learned to click through and actually look at the page if somebody sends you a request on something to see, is there a real person? Because my human mind is sensing this person is fake, right? But I don't know. But you have this fascinating thing that I've talked to you about, when we met in Singapore, about data finding data. That you can't have human beings going and keeping on finding these patterns, right? So, I mean, for me, that's a really fascinating algorithm at work. How does data find data? How do you actually do that?
Yeah. Where this notion came from is I was talking to a counterterrorism intelligence analyst at a 3-letter secret agency. And I asked him, I said, what do you wish you could have if you could have anything? And this is like right post 9/11. They said, I wish I could get answers to my questions faster. This sounds very reasonable. Like, man, who would want that? But it struck me really funny when she said that. I realized it was insane. It's insane to think that that's a goal. And here, I'll tell you why. She goes, I want to get questions to my answers faster. And I said, what happens if you ask a question today, but the piece of information you needed to make it an answerable question didn't exist quite yet? You haven't collected it yet. It hasn't arrived yet, but it arrives next week. And she looked at me and realized only the questions where the data had already happened, or the data had arrived or connected. And I go, did that happen? And she goes, yeah, that could happen. And I said, what are the chances you can ask every smart question every day? And I'm not kidding you. I mean, she's a counterterrorism intelligence analyst. She looks at me and goes, she looks at me defeated. It just goes, I can't ask every smart question every day. And that's the moment where it struck me in that windowless building. It struck me. I went, the future is where our systems, where the data finds the data and the things that are relevant find you. Then it doesn't matter what order the data arrives. It's about systems that help focus human attention. And it's such a higher order thing than systems waiting for humans to ask questions. And I've really been pursuing that. In fact, an entity resolution is, call it a building block of more layers in a stack that are going to produce real sense-making systems that integrate diverse observations and figure out when it's relevant and if it's relevant, and if so, to who. And that's really my interest. But if you don't solve entity resolution, you can't do that well. So I'm building.
And in the world you're coming in, is an entity a person, or an entity could be anything, a company, a place?
Yeah, a business, a person, a car. I mean, yeah.
So when you go in there again, you have this. I mean, this whole idea of how data finds data. I was talking with the head of Expedia's marketplace in an earlier podcast, and I asked him, what do you think AI is going to be like? What do you think your travel AI is going to be like in 2 or 3 years' time? He said, Suresh, it's really hard to say, because I said, why? And his answer was 90% of the data that the AI will be using in 2 to 3 years' time doesn't exist today. Yes, a lot of it will be the same type, but there'll be lots of new types of data. So how do you design, you talked about sense making. How do you design systems when you don't know the type of data that's going to exist? You don't know the type of problems, it's a more generalized, abstract thing.
Yeah, the answer to that is you build a generalized context computing system. So my last title at IBM was fellow, 1 of 70, but also chief scientist of context computing. And the way that I like to describe this in like layman's terms is, imagine all the yellow puzzle pieces sitting over there and the blue puzzle pieces over there, and these ones are grass, these green puzzle pieces over there. And your ability to take a pile of puzzle pieces or piles of puzzle pieces and get an understanding is super limited, because it's just piles of puzzle pieces. Like, you almost have to study each observation in isolation. Like, grab a puzzle piece and go, wow, it's red. You're not quite sure if it's a fire or a picture of a fire, But context computing and doing this in a generalized way is taking diverse observations, just like when you grab a puzzle piece out of the box. When you look at the puzzle piece, you're doing feature extraction. You're looking at like the colors on it, you're looking at the edges, and you're characterizing it. And then you look over all the other pieces that you've already assembled and stitched into your head, and now you don't take that puzzle piece and like check it on every other piece of data you've ever had. You use the features you just extracted to prioritize some candidates. And then you take that puzzle piece and figure out which, if let's say it's red and green. So you look across the board. By the way, if there's tons of red and green, you go forget that. Now you see some yellow. Now there's only 6 pieces on the board that have some yellow. And then you take that piece to go fit it there. And it's that process of integrating new observations with historical observations that you put into context, assembled. It's like taking puzzle pieces to pictures, is the way context accumulates. And the engine that we've spent $50 million building is designed to do that in a generalized way. Right now, while it's doing people, companies, vessels, cars, planes, I've designed it to, one of the stunt projects I've never done is I imagined a supercomputer building a 3-dimensional 30 billion piece puzzle, non-solvable by mankind. It's 3-dimensional pieces with colors and shapes. And if you could characterize those colors, like 3 millimeters of yellow next to 7 millimeters of red with this shape, you can feed it into this engine that I've built, and it'll assemble the puzzle on the first pass without any training data, without knowing what the puzzle looks like beforehand, as if I hid the cover of the box from you. And it's about how do
you do it without training data? I mean, I understand the human mind's an amazing thing, right? We're able to spot that thing, and without us knowing it, we consciously say, these are the attributes, we put it out there. It's an abstraction machine beyond belief. I can understand when you say you build that, but how do you do it without training data? How do you train this thing to?
All my learning algorithms work in real time without training data. And for the kinds of problems we solve, it's impractical to reload and retrain. Like, if you load billions and billions of records, and then you have, and let's say you're doing it in your data sets represents this part of the world, but then 7 families from Sudan move into town, suddenly the statistics have changed in that town. Are you going to get wrong answers for a year until you retrain? It's just not right. And so the algorithms that we've been building that do real-time learning, there's something particular that they do, is the moment a new piece of data arrives, it recasts, it increments the statistics that are occurring. And if the statistics as they are occurring in real time deviate from what you would expect, it goes, noted. And then it does two things. It goes, well, I'm not going to make that mistake again in the future. But then it also says, now that I know that, had I known that in the beginning, before I got billions of records, would I have a different view of the world? And then it fixes that in real time. And that's expensive. Doing real-time look-back learning. I'll give you a really simple entity resolution example of that. Let's just say if you have a name and an ID number, you have a good match. I'm just going to trivialize it, okay? But let's say the ID number is 98765. Now, the first time you see it, good to go. But what if, 6 months later, you have several John Smiths and they all have the same, you have John Smith and Mark Smith and Susan, and you've got like 20 people now that have the same ID number, 98765. That ID number is not a very good ID number. Somebody's maybe just using it to get, a required field. In real-time learning in our style, the moment it notices that's not a good identifier, it goes backwards in time and reevaluates all the prior things that had that and fixes them. And it does that at thousands of things a second on billions of records, so you don't have to retrain or reload. And just to bookend this is I learned how to explain this by an incredible story in Wired magazine. It said AI needs common sense. Because as you may have seen, you can change a few pixels in some imagery, and it takes the bus and tells you it's an ostrich. And then there's a picture of a temple, and you change a few pictures, and the algorithm goes, it's an ostrich again. And you and I would look at it and go, what the hell's wrong with that algorithm? How brittle is that? And when you add common sense, so the algorithms that I've been building, or my team and I have been building, have a layer of common sense so that it can work out of the box with no data. And as statistics accumulate, it's doing real-time learning. And they interact with each other. They're wrapped. And that's what we're doing that's different. And the algorithms that we are building are generalized so you could solve really interesting data integration problems beyond people and companies. But we're doing people and companies now because it's at the center of everything.
But why wouldn't somebody as you're talking, and it's so fascinating, right? Facebook says they have 2.7 billion users. I think we all know that many of them are not real. Why wouldn't, what you're building, why wouldn't be Facebook or somebody out there be able to actually solve this and say, I will only let more, or a very high probability that there's a real person in? Why is it so easy for all these large scale networks to allow so much fake identities, Suresh?
Well, two parts of that question. One part is our purpose at Senzing is to make entity resolution easy for developers. Because right now, if people building software need entity resolution, they either home grow it and they don't realize how hard it is, and now they have 20 people working on it, or to buy the good stuff, it's $1 million and it's only for the elite. And so Senzing is just making entity resolution accessible to the world. Small nonprofits with duplicates in a Christmas mailing list just download and use it for free. So I see companies like Facebook that probably have 100 people, maybe 500 people working on entity resolution aren't going to need to do that anymore. Synthetic identities is something pretty particular. It part of that solution, part of what's needed for that is entity resolution, because you're trying to match a claim with other. You don't know it's synthetic unless you can't match it to something else. And you have these issues like, did the person just age up where now they can represent themselves as a credit person? Like, they're 12 years old, they're 13 years old, they're 14 years, now they're over 13, and now they're going to start having a growing footprint. Maybe they were born overseas and they've just immigrated and they don't have any data to compare themselves to. So you have to be very careful about when you say that's a real who or not. And then there's tradecraft that people use when they're creating synthetic identities. They'll use a name and date of birth that's legit from over there, but they use a social security number from over there. And so, again, it goes back to a tradecraft is when you get a piece of data, is it true or not? You have to have other data to compare it to. And the thing about synthetic data is you need to be able to go to a registry, if you will, to see if you've ever seen any of those features, and are those features around an entity that looks like that. And if it's not, then it's at risk. It improves the risk that it's a synthetic identity, but it doesn't mean it is, because they may have been overseas. They may have just aged up. Now, to be clear, is I used to build systems that had entity resolution in them, and then after entity resolution, which is who's who and who's related to, then you score it. Like, are you doing a marketing system? Are you doing a fraud system? Are you doing a terrorism system? But we don't do this scoring anymore. Like, that never made us special. Like, is it good news or bad news? You want to sell them or call the army? Like, ow, we've kicked that out of our what we're doing, just because the work we're doing in entity resolution is so unique, and lots of people can build different algorithms on, sorting things and scoring things, and make sure no one sends me haircut ads.
So, Jeff, if you're building this thing and it can actually resolve it at this level of scale, do you actually see over the next few years or whatever it is, right? And forgetting about the business model of Senzing and all that, I'm just talking about the idea of entity resolution, what you built. Shouldn't there be a way in the planet for you to, and this could be utopian or it could be dystopian, as you know, right? Should be able to say there are 7 billion people, each of them has this identity, and the identity is something that is so deeply embedded that it can be used to certify and therefore be authentic, but also can be used in a dystopian way to surveil, to track, to do all kinds of things that you don't want to. So is that brain actually happening? And I'm going to give you a real life example of something where people have argued about both the utopian and the dystopian element of identity, which is in India, you have this thing called the Aadhaar. They have a universal ID. It's actually in the first photo ID, 1.3 billion people. It's a fantastic piece of technology, really speaking, done in a low-cost, frugal way. It allows you access to all the systems, and it's become the core of how you identify yourself. And there's also the concern about surveillance and will everything be tracked. And I'm not even going into the libertarian model. I'm just saying, where is this thing? So do you actually see these kind of brains becoming common in the next few years?
I don't know about the next few years, but I think it's definitely trending that way. The way I balance privacy with the work that we do is we don't host entity resolution and don't get any data. We don't have the risk of having it be repurposed ever, because no data flows to us. We help organizations combine the data they have rights to. A bank will have 300 piles of data, 300 different separated puzzle pile pieces, okay? And if they can get a better understanding of who's the same as who, they can address human trafficking better or money laundering better. So we help organizations make sense of what they already know. Now the question is, are some organizations are more humanitarian and say ethical than others, and other organizations, we let people download our software for free. I have to worry about like nefarious organized crime groups actually downloading my software for free and using it. And I balance that out by thinking, it's like pencils. Like pencils mainly get used for good. Now and then somebody uses the pencil and makes a hit list. I don't have a remedy for that because I'm not controlling how people use what we do. But grand scheme of things is organizations of all sizes, private sector and public sector, are trying to better integrate the data they have. And governments have a sense of wanting to understand identity. And credit bureaus in the US want to understand identity. They want to understand every single transacting adult so they can help their customers determine if somebody's credit worthy or not. And so there's these identity databases they're building. Will there be a standard de facto single? Maybe there's some reasons you'd hope for not. You'd hope it'd be a little more competitive, or there'd be some competing ones.
And that's really interesting because, it's a bit like people say that guns don't kill, people do. And, it's really in the user. I was watching this fascinating thing about gene editing and CRISPR and Cas9. And the question is, where do you draw that fine line? How do you make sure there are no bad actors, if you will, using the same technology for things that they don't want to, right? Is a story in itself. But from the vision, I'd like to come back a little bit to closer home and, our daily lives. Why, when we can resolve identity, why, when we can solve so many problems, is we still not, as a industry, whether it's in financial services or whatever, whichever industry, solve the simple problem of so much high level of irrelevance in what is being kind of communicated around the world. And it's a very common problem that every individual faces, right? I mean, your bank calls you 6 times, someone sending you mail. Why can't we solve that simple problem with so much intelligence? Even Google now gives me more ads than it gives me search results at the top of the page, right? So is this a technology issue? Is it an AI and an algorithm issue? Or is it just we don't want to apply ourselves to these problems?
Well, I mean, speaking specifically to entity resolution, which is connecting data, it's been so hard for people to do. And they end up with so many duplicates in their systems. And by the way, like you have an entity resolution problem that's personal. In your phone, you have duplicates. Imagine that. You're the only curator. You're the one entering in contacts in your phone, and you have duplicates in there because the first time you met them, you didn't know their last name, and the second time you met them, you did. And you have hundreds or a few thousand in there. Imagine organizations that have hundreds of people entering records about tens of millions of people. Imagine the problem they have. Anyway, it's just fundamental to so many basic problems, and the fact that the world hasn't really solved it in an easy way is no reason I picked it to be obsessed with.
And do you see yourself, Jeff? It's been fascinating, and I'm sure we could talk, and we have talked sometimes for long periods of time. But I just want to kind of ask you: do you see? I'm going to go back to what we said at the start. You started off solving a whole bunch of problems. You kind of narrowed it down, and you really want to focus on this one thing. Is this what you see yourself doing over the next few years? And how long do you think this obsession or this compulsion to create this is going to go on?
Well, I'm committed to commoditizing and democratizing entity resolution so it's accessible to the world. Everyone everywhere has access to world-class entity resolution that's affordable and easy to use, period, full stop. Beyond that, there's other interesting problems. And one of the very interesting problems is entity extraction, taking unstructured data and pulling out of that unstructured data names and addresses and phone numbers, figuring out what data is hidden in unstructured data. That is such an imperfect piece of
Absolutely.
technology. I mean, everybody struggles with that next. And I have really specific ways. Thank you. No, I'm good, thanks. I have very specific ways to fix that. And
That's interesting.
I'm blown away that the world hasn't already fixed it. Like I'll chat with people that are running these entity extraction companies, and I say, hey, we're the beneficiaries downstream. Entity extractors pull structure out of unstructured data, and then they hand us that structure. So I'm the beneficiary, and they go, yay, and I go, I'm the victim. And they know exactly what I mean, because the imprecision is that poor. And I know that I believe they're all, I'm using all here on purpose, is for all the companies that are in that business that I've talked to, and I go, hey, your accuracy needs to go up. Well, if I say to them, hey, if I doubled your total budget you've ever had, could you close your error rate in half? And when they say no, they can't close their error rate in half if I doubled their historical R&D budget, then they're on the wrong method.
True.
It's fundamental. And I know I've been inspired by biology and the way the hippocampus and the neocortex interact with up and down pipes. And there's some clues in there that I think they're missing. Anyway, I'm going to get onto that next once I finish with liftoff of my starship. Meaning,
we'll talk about that in the next edition. But Jeff, once again, fascinating talking to you. And thank you for being on the show, and thank you for demystifying this whole idea of how entity resolution is. I mean, it's obviously a universal, ubiquitous problem in every enterprise. I love when you talk about my phone in the contact book. I mean, I'm wondering when you're going to launch something where I can just use it and deduplicate and solve this thing.
You do it right
I think
now.
that is a problem.
You can literally just export your contact list to a CSV file, download my free product. It'll tell you all your dupes. I mean, you have to go fix them, but it'll tell you every single duplicate that you have. And you can do that in 4 minutes.
And I'm going to go and do that because I just realized I have so many contacts out there that I don't know how they got there. I didn't enter them. But we all have that problem. But I think it talks to the universality of the problem that I think all of us face in our life. And thank you very much for demystifying that. And thank you very much for being on the show. And look forward to speaking to you again.
Yeah, good seeing you again. Adios.
Thank you. Bye.
We have new episodes coming out every week, sometimes twice a week. Each will seek to bring a different and fresh perspective to the topic. Please subscribe to the podcast channel and share it widely in your network. I look forward to speaking to you in the next episode. Meanwhile, stay safe personally in the age of COVID and stay relevant professionally in the age of AI.